Hi everyone, myself Bidyulata Sahoo, working as an assistant professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is my 29th video lecture on the course Applied Artificial Intelligence. Today I am going to discuss about the fuzzy logic control, or we can say the fuzzy logic architecture. These are the topics to be discussed. What is the formal definition of the fuzzy logic control? It is shortcut, it is called as FLC. And what are the key components of FLC? And what are the applications of fuzzy logic control in artificial intelligence? Few advantages and disadvantages. This is the topic learning outcome for fuzzy logic control. After the completion of this topic, students can discuss the fundamental concepts of fuzzy logic to handle uncertainty and imprecise information in decision-making processes. Already I have discussed in my previous video what is fuzzy logic and how it looks like, and how the crisp values will be are converted into the fuzzy values. Especially the fuzzy logic is used to handle the situation which is fuzzy. First of all, it is not a logic. It can handle the situation which is fuzzy, means uncertain or imprecise. That means the knowledge or the data which is vague or does not have the correct information or does not or imprecise, then in that case fuzzy logic is used. Let me discuss about the formal definition of the fuzzy logic control. So fuzzy logic control, first of all, it is a rule-based approach. In my first video lecture of the fuzzy logic, already I have discussed, it is a computational paradigm because it consists of various frameworks. It depends upon, especially depends upon the mathematics, one part of the mathematics which is called as the set theory. In my, I think 26th or 27th video lecture, I have discussed about all the fuzzy mathematics or fuzzy sets. You can go through that video. So as fuzzy logic, it is a computational paradigm because it is a combination of various framework like mathematical framework, integration of the soft computing. It is a rule-based system. So this is one of the framework which is called as the rule-based approach. Especially in the fuzzy logic control, various rules are defined by the expert or the people, those who are expertise in their particular domain. The rules are defined using if-else rule. So that is why it is called as the rule-based approach in artificial intelligence, which can handle uncertainty and imprecision, making it suitable for complex systems where exact models are difficult to define. So instead of using the strict binary logic, which are called as the true and false, fuzzy logic control operates with the degree of truth, allowing for the smooth and adaptive decision making. That means what? In case of the binary logic, which is called as the crisp logic, which accepts only two values, either true or false. But our fuzzy logic control, nowadays many things are uncertain. Okay, so uncertain situations, it cannot be handled. Like in our, if you take the example of the washing machine, depending upon the dirtiness of the cloth, the water flow will increase or it will be decreased. So all these increase, decrease, or the amount of water will be decreased or increased, that depends upon the configuration of the fuzzy logic. So that is why. So it is not like that the cloth is very dirty, that much full amount of water is needed, and the cloth is not dirty, no water is needed. That belongs to the crisp set or the binary logic. If we follow that logic, then our system may not work properly as per our requirements. So to overcome that problem, so fuzzy logic is used. So fuzzy logic operates with the degree of truth. With a certain value or with a certain change in value, the corresponding value can be determined by the fuzzy logic. That is why fuzzy logic is used, and the corresponding value, what I said, that can be converted using the membership functions. This is what the controller looks like, the fuzzy logic control, which consists of four important components. One is the fuzzifier module, second one is the defuzzifier module, third one is the intelligence, which is called as the inference engine, and the fourth component is called as the rules or the knowledge base. Okay, as already I have discussed in my previous video, already I have introduced, let me discuss once again. So these are the four important components: fuzzifier module, defuzzifier module, intelligence, which is called as the inference engine. This is called as inference engine. This is called as inference engine, and this is called as the knowledge base. This is called as the knowledge base, right? So what is the meaning of this fuzzifier module? So fuzzifier module, always it converts the crisp input to the fuzzy inputs. Crisp inputs means in the form of real numbers. It may be 20, it may be 30, or it may be 40, like this. Suppose I'll say the temperature is 20 degree. Okay, so 20 degree means I can write mu of 20 degree. It can be set to 0. Okay, suppose mu of, I'll write 30 degree. 30 degree I can write, it may be like 0.5. Okay, and mu of 40 degree, so let it be 1. Okay, if we take the example of temperature, so at the 20 degree temperature, the corresponding value, the membership value, it can be 0. We can assign, it can be 0, it is not 4, it can be 1. Okay, so mu of 30 degree, at the 30 degree the temperature may be partially hot, so it can, the membership value can be 0.5, and at the 40 degree, which is very hot, we can write the membership value as 1. How these conversions are happen? Using different membership functions, already I have discussed in my previous video, you just go through. So fuzzifier module is responsible for the conversion of the crisp input to the fuzzy input. Then after the conversion to the fuzzy input, that will be provided to the inference engine. Inference engine, it is an engine which can infer the result by consulting with the knowledge base. So knowledge base, it is the main important component of the fuzzy controller design, which consists of various rules or various conditions which are acquired from the experts or the human experts, those who are expertise in their particular domain. And the expert people, they define the rules in the form of if and if then rules. Those rules are stored in the place of knowledge base. So inference engine, what it does, whatever the fuzzy inputs comes from the fuzzifier module, it tries to map with the rule base or the knowledge base and try to find out how many rules are matching with the fuzzy inputs. Depending upon the matching, that many number of rules will be fired, and it produces the fuzzy output. That fuzzy output will be provided to the defuzzifier module, which will convert again into the crisp output, because crisp output we can understand, the user can understand, and here crisp input user can understand, but the controller does not understand those crisp values in the form of real numbers. So it always converts all the values, all the real number values between 0 to 1. So this is what the diagram says, or the fuzzy logic controller architecture says. Consists of these four components as I have discussed. So here I have mentioned everything. So key components of the fuzzy logic control, four components: fuzzification, rule base, inference engine, and defuzzification. So fuzzification, which converts the crisp input, means the numerical data, into the fuzzy values using the membership function. Here you can see the example. If the temperature is 30 degree, it can be represented as warm with a membership value as 0.7. And if the temperature is hot, with a membership we can assign as 0.3. Okay, that means the conversion from the crisp set to fuzzy set, that can be done with the help of fuzzification module. The second one is the rule base, which contains all the rules and the if then and condition offered by the experts to control the decision making system. Here one of the example I have given: if temperature is high, then fan speed is fast. So like the temperature, depending upon the situation, all possible conditions would be stored inside the knowledge base or the rule base. Third one is the inference engine, which can determine the degree of match between the fuzzy input and the rules. Okay, according to the input field, it will decide the rules that are to be fired. So combining the fired rules form the control action. Then the fourth component is called as the defoggification, which converts the foggy output values into a single crisp value for the real world. So for the conversion of the foggy output to the crisp output, various methods are used, like the centroid method, max membership method, or weighted average methods. Let me discuss about various applications of the foggy logic control. Especially the foggy logic control can be used in the industrial automation, like controlling the robotic arm and manufacturing processes also. It is used in the air conditioning system to control the temperature, to set the temperature of the AC based upon the room's temperature condition, and autonomous vehicles which can handle the uncertain traffic at any point of time. Even it is also used in the medical diagnosis. It can suggest some diagnosis for the patient of with uncertain prescriptions or uncertain knowledge or uncertain data. So in various applications are there apart from this also. Now these are the advantages of foggy logic control in artificial intelligence. It is very cheaper compared to other controller, and it is robust. Robust means irrespective of any application, this foggy logic control can be used. It can be sustainable, and it is customizable. Customizable means according to the user requirement, the rule can be edited or rules can be modified in the knowledge base. And if we modify the rule accordingly, the foggy logic control will work. And it is reliable also. It is much more reliable because it can give the correct result as per the user requirement, and it is efficient also. These are the various disadvantages of the foggy logic control. It requires lots of data. How it requires lots of data to manipulate all the crisp values, or to understand or to find the foggy values using the membership function for each crisp values. It requires the rules or requires the knowledge inside the knowledge base. That is why it requires lots of data. It needs high human expertise. That is what I have discussed, especially in the knowledge base. Human expertise has to give their expertise in the form of rules, in the form of if-then condition, and it needs regular updating the rules. Suppose our system is going to be changed and we want to modify the controller completely, then we need to update the rules also. So these are the things which takes lots of time, as well as for all the things it requires human expertise especially. So these are the biggest disadvantage of the foggy logic control. So this is all about for this particular video. I hope you might have understood the foggy logic architecture or the foggy logic control. So for the preparation of this video, I have referred this book like Soros Cosic for Artificial Intelligence, and I have referred this website also, which is visible on the screen. I hope you might have enjoyed. So next class I will discuss about the foggy hedges, as well as I will discuss one more important topic, that is neuropoggy system. So till then, take care. Thank you. Bye.
Like, share and subscribe. Hit the bell icon for more updates.